a couple things, just to kind of put everything into perspective, okay? Where we are right now is you all have taken a look at your water, and you've studied the filtering. We've decided that we were going to move the particle matter from the water, okay? And we looked at the science side of it. You looked at different possibilities of and the characteristics of the components and how it was going to take those particles out of the water, okay? And you made models of it. Now, when we say model, everybody thinks, okay, we're going to build something, and it's got to be a 3D model. That's not necessarily the case. And to put everybody at ease, we actually have another really good modeling activity that probably should have come before this, but it's okay. And you're going to understand the modeling component of it a whole lot better when we do, I believe it's tomorrow, right? I think we have it set up for tomorrow. So it's just on Wednesday. That's just modeling. Okay, so that'll make sense. When modeling, we gave you a chance to work on it individually. All right? And when you're doing this with kids, you always want to kind of go through this sequence. So you start out with it individually, and then you look at each other's models and come to a team or a group consensus, which is kind of where you're now, okay? With the next activity, you're going to have a chance to critique, go back and look at each other's and question, and really look at what's going to argue a little bit. Okay, and based on evidence, and then you're going to have a chance to refine the model. So basically, right here, we stopped at that process. Okay, filtering, and we've looked at the science as analyzing and observing all of the different components of your filtering materials. Okay, you developed a team model, and now we're going to jump over to the engineering side. Okay, and we're going to work on the design. Does that make sense? Okay, so does that kind of put everything in perspective, in picture, whatever? Thank you. Okay, so once again, this is, yes, Kevin.
Well, part of that original stuff, there should have been time for us to, because when we start putting some of these things together, they're going to act totally differently than when they were one-on-one. Unless you're going to do one and then one. But if you're going to layer them up, they're going to start changing because of how porous they are or not. And it's going to change how the water goes through.
Okay, so that was the component that you were supposed to get, the porosity. Porosity of the filtrate or filtering material, and then also the particle sizes and how they react with each individual thing. So even your design might be something very generic, as something that's going to filter out the coarse stuff at the top, and then what filters out the medium-sized stuff, and then maybe what filters out the small stuff, and understanding that there are different size particles. That's where we were going with it. There are different size particles in the solution, okay? And you're right, it's maybe it depends on the order, okay? And some of you guys, I noticed, look at this one right here, the one with the green title. They've got gravel on top, and then they've got the landscaping material, so apparently the water flowed pretty freely through that, and then they get into the sand, which is a little bit finer, and then maybe the coffee filter. Which group is that? That's this group. Am I right? Or go ahead and help me with. Was that your thinking?
Yeah.
Okay, so on theirs they're looking at they're looking at the speed maybe at which it flowed through and the size of the particles that were picked up in each individual layer. Did anybody else have something similar to that? Okay. Oh, there you go. Okay, look. So they've got the charcoal, and then the coffee filter, and then the sand, and another coffee filter.
We felt the through very slowly. We were even having to squeeze.
Oh, okay.
Water didn't come out at all.
Okay.
So what I'm saying is when we're putting the, for example, the landscape, gravel, the water.
Hey, guys, let's listen. Okay, I understand. So if we had a whole lot more time to play with this and experiment with it, we could go back over and look at maybe the best way to put it together, okay? All right, so that kind of gives a picture of where we were at. So basically, you guys stopped right here, okay? All right, you're again going to go back Now the design part. We've got the idea. We know what we're going to build. Now it's time to build our system. Now you're putting things together. Now you're going to see how it works. Okay? Keeping in mind your criteria. How is it? What is it going to look like in the end? That coffee brown. Where did I put it up here? Your criteria. So it's going to be light brown, minimal sediment, no oil, no foam, smells natural, and no dead animals. Okay? Okay, so your let me think. Hang on. Your constraint, again, you're going to be limited to what you have within this room at 20 minutes. Okay? Okay. This is the piece we're getting into the design portion. Everybody was handed a packet, and at the back of your packet, you have a purple piece of paper. That's the divider. Now, this is done individually, okay, because we're actually going to get into sharing it very carefully, all right? So what you're going to do is you're going to fold it. Hamburger, please. Okay, landscape. Hot hamburger fold, please. Okay, so what you're going to do is I'm going to give you, you're going to draw 2 designs. I'll give this back to you. You're going to draw 2 designs. Each individual person is going to come up with 2 designs. Okay, 3 minutes? 5 minutes? See, it says 2. I'm going to give you 3 because I'm nice. Okay, so you're going to have 2 different designs. Okay? Individual, which means you're not saying a word to anyone else. Okay? Minimal number of words, so draw arrows and label. Okay? And you're not going to discuss it with your partner. I'm going to give you get your design. When you're done, put your pencil down so I can see that you're done. And then what we're going to do is we're going to share, but I'm going to in a very specific way. Okay? Ready?
Are we
Questions?
Same criteria?
Same criteria, yes. You want the water, the same criteria. Now you're putting it together. Now we're going to engineer a water filter that's going to give us our end criteria because we're going to build now. This is our design model. How are you going? What's it going to look like when you build it? Okay. The others was just understanding filtration. Now we're going to build it. Okay? Which some of you have you've already understand. That's why I'm only going to give you 3 minutes, okay? Any other questions? Yes?
If we were working with students
Go ahead and start if you
and we had gone in this process, would we have all shared out our models and now we're building based on seeing other people's models, or are we drawing a design still based on only looking at our own?
This is where you would have critiqued each other's and refined it, and you're going to understand that on Wednesday. Right.
Oh, they thought of that. Okay, no, okay.
Right, right. Okay, so yes, this is where we stopped, okay? So, yes. You guys are stalling so you get more minutes. No, I'm just kidding. Raquel?
We were asked to not do like a model of the whole filter and just do like one of the elements and
Right.
show which one like we had selected. So
Now it's everything.
that's what we were all supposed to do, and then look at the different elements and then combine them to make the perfect model, right?
Your model was, it could have even been generic. Can I share with what you drew, Kathy? Am I allowed? Never mind, you're not listening, so I'm going to do it. Okay, I know. Okay, so like for instance, what the model before, basically you've got several different size particles in solution. Okay? You've got different materials that filter at different rates. So say this is a piece of hardware cloth. Maybe this one is a mesh that's a little bit finer. And then this one is really, 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 really fine. So understanding that the bigger particles are going to stop here. Understanding that the medium-sized particles are going to stop here. And understanding that this one is going to be the smallest particles and that maybe even you've got the tiniest particles going through. So that would be our model. Understanding what filtration means, particle size, porosity, that's where we were supposed to be headed. Okay? So now what you're doing is you're taking all of your materials, you're designing 2 designs, 1 on each half, and don't talk to each other. 3 minutes, go.